Now we will discuss another factor which influence the ionization potential, that is penetration effect. This penetration effect is nothing but attracting power of nucleus towards the electrons. That means if electrons present in s orbital, the attracting power will be varies when electrons present in p orbital or d orbital or f orbital. That means depends upon the shape of the orbital, the attracting power of the nucleus is different. That is called penetrating power or penetrating effect. That means the degree of attracting power will vary from one orbital to another. That is called penetrating effect, because all orbitals does not have same shape. So depends upon the shape of the orbital, the attracting power of a nucleus towards the electrons is different, will vary. That is, for s orbital this penetrating power is very high, and then p and then d and f. This s orbital have a shapes like circle. This s orbital have a shapes like circle. So the attracting power of the nucleus on s orbital is very uniform because of the circle shape. But in the case of p orbital, it has a dumbbell shape. So the attracting power of the nucleus on p orbital will less. For d orbital this is double dumbbell, and for f orbital it has some fused shapes. So depends upon the shape of the orbital, the attracting power or the penetrating the electrons by the nucleus is varies. That is higher for s orbital and p orbital and d and f. That means the removing of electron in the valency shell will varies. If the f orbital is present, it requires small energy. If the electron present in d orbital, it requires further more energy. If electron present in p orbital, it requires further more energy. If it is present in s orbital, it requires more energy compared to the others. That means the ionization energy is more for s orbital, and then p orbital, and then d orbital, and then f. That means the number of electrons present in all cases is same, then ionization potential will varies depends upon the shape of the orbital, or nothing but this is penetrating power of the orbital. That penetrating power is more for the s orbital, and then p, and then d, and then f. So if electron is present in s orbital, that is closely tightly towards the nucleus. So the removing of electron from the s orbital is difficult compared to p, and when compared to p and d, the packing of electron towards the nucleus is strong in p orbital compared to d, and compared to d and f, the binding capacity or the tightly packing capacity of electrons towards the nucleus is more compared to f in the d. So the electrons in which orbital are present, it varies the ionization potential. That varies high for s orbital and p and d and f. And next factor is electronic configuration. In generally, the configurations of electrons which are having half filled or fully filled are stable. We already discussed inert gases having fully filled configuration in their valency shell, which has usually having inert gas configuration, that is ns2 np6. That means most of the elements are readily wants to get this configuration, that is fully filled configuration. Those are very stable. For s orbital it is s2, p orbital p6, d orbital d10, f orbital f14. These are fully filled orbitals. And another case is half filled, that is p3, d5, f7. That you can see p3, it has a 3 suborbitals. Each suborbital have one electron. In the D, it has 5 suborbitals. In each suborbital, it has another electron. Like in the same f orbitals also. That means in each orbital, if one electron is present, that is half-filled configuration. This half-filled configuration also gives some extra stability for the atom. So when the atom is more stable, then the removal of electron from the atom is difficult. Hence, you need to give the more energy to remove the electron. So the ionization potential will increase. That means when an element have fully filled or half filled configuration, it becomes stable. So removal of electron from stable element is difficult. In that cases, we need to apply the more ionization energies. From this you can say the elements which are having fully filled configuration or half filled configuration, those requires the more ionization potential to remove the electron. Take a simple example, beryllium and nitrogen. Beryllium have fully filled configuration, that is 1s2, 2s2, and nitrogen, in this case 1s2, 2s2, 2p3. This has half filled configuration. This half filled configuration and the fully filled configuration gives some extra stability to the element. So to remove the electron from those elements is becomes difficult. It requires the more energy. So the ionization energy is more for fully filled or half filled configurations.